When drawing Lewis structures for molecules, we generally try to follow common bonding patterns. And these common bonding patterns are that boron likes 3 bonds, carbon wants 4, nitrogen likes a lone pair with 3 bonds, oxygen prefers 2 lone pairs and 2 bonds, and fluorine likes 3 lone pairs and 1 bond. Now, we don't always have the case where we get to follow these common bonding patterns, but if we don't, then our molecule is going to have formal charges, which we'll talk about later in the chapter. Let's give this a try. So let's try writing the Lewis structure for nitric acid. So we're going to start by writing the skeletal structure. So we want to make sure that our least electronegative element is in the center, with the exception of hydrogen. Because hydrogen only makes 1 bond, it is always going to be on the outside of our molecule. So in this case, nitrogen is further left on the periodic table. So nitrogen is going to be in the center. Our oxygens are going to be around the nitrogen. And because this is an oxy acid, so hydrogen with a polyatomic ion, our hydrogen is going to be attached to one of the oxygens. Now, we do need to count the number of valence electrons that we have in order to determine how many electrons we can use in the structure. So our hydrogen has 1 valence electron. Our nitrogen has 5 valence electrons. And our oxygen has 6 valence electrons, but we have 3 oxygens. So if we add up these valence electrons, we come up with 24 electrons that we can use in our structure. Now, if we did have an ion, if it was negative, we would add an electron for each negative charge that we had in our ion. And if it was positive, we would subtract 1 electron. Now that we have the general outline of our structure and the number of electrons that we have to work with, we know that they have to be connected by at least 1 single bond in order to be a molecule. And so we are going to add a single bond between each of the elements. And remember that bond represents 2 electrons. So by drawing these bonds, we have used 8 electrons. We have 16 more electrons to use in our structure. So now we want to complete the octets for our outside elements. We know that we have 16 electrons left. So we want to make sure that we fill up our oxygens. That uses all 16 electrons that we had. We have no more electrons to use. That hydrogen is already complete because it's forming 1 bond, and so hydrogen doesn't get any more electrons. We've completed the octet for each of the oxygens by adding 6 electrons in lone pairs to the right and the bottom oxygen, and 2 lone pairs to the oxygen on the left, which already has 2 bonds. So if we examine our structure, we can see that our outside elements are completely filled. We've used all of our electrons, so we have no more that we can use. We want to make sure that we have all of our octets completed. So our oxygens and our hydrogen are all right. They have the amount of electrons that they want, but our nitrogen is not. We do not have any extra electrons to put on that central atom because we've used them all completing the octets for the outside elements. Because our central atom does not have an octet and we have no additional electrons to use, we are going to share electrons from our outside atoms to that central nitrogen. So nitrogen only has 6 from the 3 bonds that are drawn. We're going to take a lone pair and make it a double bond in order to share those electrons. So now by doing this, each of our oxygens has an octet. Our hydrogen has a duet or 2 electrons. And by sharing and making that lone pair, now that nitrogen in the center has 8 electrons, 2 from each bond that it has. Remember, bonds count towards both elements. Here's a practice for you to try. Pause the video and draw the Lewis structures for the following ions or compounds. Carbon dioxide. If we add up the valence electrons, carbon has 4 electrons and each oxygen has 6. So we have a total of 16 electrons to work with. We want to put the least electronegative element in the center, which is our carbon. And we draw the oxygens around the outside. We know there has to be at least one bond holding them together, which uses 4 electrons. We have 12 left. We write those 12 electrons around the outside element. That uses all 12 of our electrons. We have none left to put on our center carbon. So our oxygens are happy with 8 electrons, but our carbon is not. Because we don't have any additional electrons to use, we need to start sharing our electrons. And typically we are going to share in a symmetrical fashion. So we are going to form a double bond on each side of our carbon. Now our carbon would have 8 electrons and both of our oxygens would. Our SeOF2, Se is going to have 6 valence electrons. Our oxygen is going to have 6 valence electrons, and each fluorine is going to have 7 valence electrons. This gives us a total of 26 electrons to work with. We want the least electronegative element in the center, which in this case is the selenium. And we draw the other elements around the outside. We know that we have to have at least a bond holding them together. That uses 6 electrons. We have 20 left to use. We fill our outside octets. That uses 18 of our electrons. We have 2 electrons left over. Because at this point all of our outside octets are full and we have electrons left over, they are going to go on the center atom. And so now each one of our elements has an octet, including our center atom. N2O, so this is nitrite. Nitrogen has 5 electrons. Each oxygen has 6 electrons. And we have an additional electron from the negative charge. And so we have a total of 18 electrons to use in our nitrite. We want the least electronegative element in the center, which is our nitrogen. draw our oxygens around. We know that there's at least one bond that holds them together. We have 14 electrons left. Fill our outside octet, or the octet on the outside elements. That uses 12. We have 2 left. Those are going to go on our center element. Now we need to check our octets to make sure that they are complete. Our oxygens are good, but our nitrogen only has 6 electrons, 4 from the bonds and 1 or 2 from the lone pair. So we are going to have to share electrons to complete our octet. And now by making a double bond to one of the oxygens, we've completed the octet for all of the elements. If we look at H3PO4, this is an oxy acid. We add up our electrons. We've got 3 times 1 electron for the hydrogen. Our phosphorus has 5 valence electrons, and our oxygen, each oxygen has 6. So we've got a total of 32 electrons to work with. Our hydrogens are going to be attached to the oxygens, and phosphorus is further left and down than oxygen, so it is going to go in the center. And our hydrogens are connected to our oxygens, and we have to draw a single bond to each element. So that uses 2, 4, 6, 8, 10, 12, 14 electrons. We have 18 electrons yet to use. So we're going to start filling the octets on our oxygen. So we've got 6 on the oxygen without the hydrogen. That uses all 18 electrons. We have none left. If we inspect our octets, each one of our oxygen has an octet between the bonds that are drawn and our lone pairs, and our phosphorus has an octet. Our hydrogen only has 2, but hydrogen only wants 2. So this would be the Lewis structure for our phosphoric acid. Sulfite. Sulfur has 6 valence electrons. Each oxygen has 6 valence electrons, and we have 2 additional electrons from our charge. So in this case, we have 26 electrons to work with. Our sulfur is going in the center. We draw the oxygens around it. It's going to use 6 electrons to draw the bonds. We have 20 electrons left. Fill the outside octets for the oxygen. That is going to use 18 electrons. We have 2 electrons left that we're going to put on the center element. So now if we inspect our octets, everything has 8 electrons, which is what it prefers. Phosphorus. Each phosphorus has 5 valence electrons. Each hydrogen has 1 valence electron. So we have a total of 14 electrons to work with. Now our molecules typically want to be symmetrical, and so our phosphorus, we have actually 2 central elements in this case, which are our phosphorus that are attached to each other. We're going to draw it symmetrical because typically that's how our molecules prefer to be. So drawing those bonds, we've used 10 electrons. We have 4 electrons left. Our hydrogens, we can't add any additional electrons to them. They only want 2 electrons. So we're going to split those 4 electrons between the 2 phosphorus atoms. That completes the octet for the phosphorus. And so this would be our Lewis structure.